Hello, everyone, and welcome to the webcast. Today's webcast is about data mesh, and I'm glad you can join us. So let's just take a look at what we'd like to cover for the next 30 minutes. We'll start with some high-level introductions to ourselves and to Thorogood, and then we'll get into data mesh. We'll just talk about what data mesh is, a high-level overview of it, data mesh in practice, and why it matters. So introduction. So my name is Harpreet Chima, and I am a data and analytics consultant at Thorogood, and I'm joined here today by my colleague Ben Dunmeyer, who's a senior data and analytics consultant at Thorogood, and we both will be presenting the content today. Introduction to Thorogood. So who are we and what do we do? So for the big picture, we help our customers make sense of their data. We are an independent and specialist BI and analytics company with a focus on data engineering, data science, and data visualization. Our approach is rooted in understanding business goals and using the capabilities of technology to meet these goals. So customers and business objectives are at the forefront of our approach. We are a global company with offices and consultants in Asia, Europe, and the Americas. We offer a full range of services when it comes to data and analytics. That includes data and technology strategies and roadmaps, end-to-end implementation of cloud solutions, user empowerment, and analytics services. We are an independent consultancy, meaning that while we partner with many of the leading technology providers, we're not tied to one specific tool or platform. So this allows us to understand an organization's technical landscape, understand the key business objectives, and provide an unbiased perspective on the ideal technical design for a solution within those parameters. It also allows us to stay up to date with technology updates across the industry so that we can develop robust, modern solutions for our customers. Getting into data mesh overview, what is data mesh? Data mesh is a term that was coined by Zhamak Dehghani. She's a director of emerging technologies at ThoughtWorks North America, and she was the one that founded this concept of data mesh and coined this term. So data mesh has picked up steam in the major cloud providers as well. AWS has said that we've been talking about data-driven organization model for years, which consists of data producers and consumers. GCP, Google Cloud provider, has also has an offering called Dataplex, which simplifies the enablement of the data mesh architecture. Ultimately, data mesh doesn't demand new technology, but it is really just different approaches to using the modern cloud data storage and analytical tools. So there may be organizations now that are using the different principles of data mesh without even knowing it, since it is more of a architectural strategy rather than a shift in technology. Data mesh consists of four core principles, and we'll take a look at these principles now. So the first is domain ownership. This mandates that the domain teams take responsibility for their data. According to this principle, analytical data should be composed around domains, similar to the team boundaries aligning the system's bounded context. So what this means is data is split up into domains, for example, like the finance domain or the marketing domain, and those teams themselves own the data. So they're the ones that are owning the data. They're the ones that are cleaning it, transforming it, loading that data. And they're the ones that work most closely with the data. So they'll have the best business understanding. So that's the reason why of this concept of domain ownership. Next is data as a product. So this projects a product thinking philosophy onto analytical data. This principle means that there are consumers for the data beyond the domain. The domain team is responsible for satisfying the needs of other domains by providing high quality data. So this concept, what they're trying to say here is that data is treated as a product. So as data is coming in and being used by the different domains, they're also looking to serve that data to other domains. And that's where this whole mesh concept applies with the cross domains can use the data of different domains. That way, everyone has data within their own domain and they're serving it. And going back to the same example, a marketing domain can then start using data from finance if need be, if they have some business use case where they need that data. The third is a self-serve data infrastructure platform. So is this to adopt a platform thinking to data infrastructure? It's a dedicated data platform. Team provides domain agnostic functionality, tools, and systems to build, execute, and maintain interoperable data products for all domains. So this principle talks about having a self-serve data infrastructure platform in terms of it's a platform where there's a data catalog where all the data can be stored between the domains, and anyone can go into this data platform and use the data, like we were saying, like data as a product. So using that data in the self-serve platform. And the last main principle is federated governance. So this achieves interoperability of all data products through standardization, which is promoted through the whole data mesh by the governance guild. So here it's like defining global policies, defining some formats, defining different structural policies so that all of the data that's being stored, where it's being stored and how it's being stored is the same across all domains. It's a way to just kind of make sure that everything will be in the same format, and when domain team is trying to use data from different domains, it's not completely different. So there's some sort of standardization. So here we have a diagram which kind of puts all four principles into one picture. And I'll just highlight the different principles and why they're important. So the first is, of course, the domain. So we have the data product, we have the domain team, and as you can see, this domain team is loading their operational data. So they're the ones that are ingesting it. They're doing their analytical analyses on the data, their different analytics. And then finally, when they're done, they're publishing their data as a product. So this allows other domains to use their data. They can access that data by going to the self-serve data platform. The next key thing is the federated governance. So in order to publish that data, and when they are publishing it, they have to make sure that all of the different policies, like for example, security, privacy, documentation, interoperability, so the format of the storage of the data, the format of the files, and the different other standardization that is defined by this team will be from federated governance will be in this domain. I think the next will be self-serve data platform. So once you have federated governance and you have domain and you have your domain product, we have the self-serve data platform. This is where teams can go in, they can go to the catalog and they can see which data is available. They can query the data. They can go in and have some monitoring. And this is where the infrastructure is set up for using the data. And finally, there's an enabling team here. This is showing a team that is kind of guiding the approach of going into data mesh. So here we have this team which can give help to the different domain teams in terms of best practices. It can help with the ingestion. So this is a team that kind of guides the team towards this architecture of data mesh. Let's just take a look at how data mesh builds on current practices and strategies. So the first is data location. Compared to data lakes, data mesh does not have to be stored in a centralized location and can be scattered across various sources. In terms of data control, data mesh gives control of the data to the team that is owning the domain rather than a single data team handling all the data in a data lake or like a data warehouse. So there may need to be a more shared control of decisions and shared enforcement of practices, which is where federated governance comes into play. So that way, even though data is being owned by different domains, there is some sort of standardization and governance that is being followed. And finally, the data mesh architecture for storage can be used in the current popular data storage within cloud providers like S3, ADLS, Google Cloud BigQuery. And so modern tools are really popular for this because they offer limitless scalability, relatively affordable storage, and automated scaling and a maintained infrastructure. So you don't really have to rely too much on the domain teams of having like a really full IT background because they don't have to worry about the infrastructure maintenance and they can just use what's coming out of the box for these from the cloud providers. Now let's just take a look at a high level application of data mesh principles to a data lake architecture that may already be in place. So here, just some strategies. So if we did have a data lake and we were just wanted to take a look at just applying some of the principles and how we would apply those principles. In terms of data ingestion, domain teams can use common techniques to bring data into the platform, such as using ETL loads, streaming ingestion, SQL DB loads, etc. So these loads can be either new or they could be previous pipelines that have already been ingesting the data. Next would be governance. So defining global policies for domain teams so that they can format, store, and share data the same way. This can include defining access control policies, creating a data catalog, and defining a file format for the data to be stored as. Also, data stored in the lake will be split up into different domains, and the respective domain teams will be assigned owners of the data. So as we were saying, data would be split up into domains, and then those domain teams will be owning that data. So these teams will need to be capable of transforming, cleaning data to the standards defined in the global policies of the federated governance principle. And then also, as we were looking at the diagram before, an enabling team in place to facilitate the adoption of data mesh architecture, and this will help drive not drive the principles, and they'll just make sure that the best practices are being followed and that everything is in order for the data mesh architecture to be in place. So now we'll take a look at data mesh in practice, and I'll be handing it over to my colleague Ben now.
So like Harpreet said, he's kind of introduced the concepts around data mesh, and I'll talk about where we're seeing these principles already being applied, some of our kind of editorial on the concept and it's kind of gaining in popularity, kind of mimicking some of the things that Harpreet was talking about. Right now, the general strategies that we're seeing is a centralized data lake with some like reasonable central control. So we might be pulling all data into a single data lake, maybe a few different geographies or something like that, but following similar patterns, similar organization, probably some similar standards, and it's existing together. There's certainly some kind of overall technical governance in terms of the core infrastructure, the networking layout, the stack of tools that are used, and ensuring they follow like security and compliance standards. Of course, different across organizations, but we are seeing a good bit of standardization of ingestion. Most see ingestion as a fairly kind of routine activity, and that it's kind of similar no matter what you're connecting to, or similar no matter different domains. So we're seeing that kind of attempted to be done at scale, very similar pipelines, and just kind of copy and paste, so to speak, and to varying degrees of success. And then different terms, center of excellence, Harpreet used enabling team in some of the data mesh documentation, but really groups that are thinking about what is the data architecture, how's it evolving over time, how are we providing development environments, what are some of the best practices and standards that we want to apply across the organization. So with data mesh, some things change, some stay the same. So there's still that need to have the definition of infrastructure, the management of one's network, all that sort of stuff. And there's still some role for center of excellence, enabling team, whatever the term is, but really thinking about like how does this all work together? And I think the additional roles within data mesh is that collaboration and definition of ownership and the, let's say, organization across the different domains, because that kind of presents a new challenge. So you kind of need everybody working together on it, but you might have a single unit that is really focused on that like definition of domains and the support that domains need to have enough standardization and enough similarity that things coalesce nicely. And then the actual data products or domains, which we could think of existing in a centralized data, like maybe just splitting out into different chunks. And then really a part that I think is pretty tricky is what's the integration look like? How are we connecting entities across these domains? How are we technically providing access and enabling connections to different data stores in different places? So really, if we think about flows of data, maybe we simplify it into a single thread. Like naturally, data takes different levels of maturity. Some will use the bronze, silver, gold, raw curated, or raw process curated, different naming conventions, but kind of the process exists. So I'll talk a little bit about that, but see where we might be thinking about the principles of data mesh applied a little bit differently to how this is maybe done centrally. Sourcing and ingestion, often connecting to disparate data sources, and there's always some sensitivity here around like storing of credentials, knowing rules and regulations around retention or those sorts of things. So we collect the data, generally creating some sort of raw but interoperable layer, so not applying any transformations to the raw data, but making it in a generic or a pretty easy to use format in some kind of shared location. Usually then there's cleaning on that base data, so we're not talking about aggregation or filtering or integration, but rather the kind of cleaning of columns. And usually here we're seeing business logic applied, so whether that's derivation of new columns or specific rules that are applied on raw data to make it interpretable and able to be used. Then comes the integration of data, and this could be integration within like a single domain or a single star schema model, but likely also integration of other disparate data sets, maybe pulling together supply chain and marketing and finance data all in one. But here we're doing some sort of alignment, aggregation, maybe introducing quality checks, referential integrity checks, circuit keys, all those sorts of things. And really where you'd think you need to cross domains or have the potential to cross domains. And then lastly, simply the analysis, and this could be the application of machine learning models, data visualization screens, experimentation, just ad hoc querying. And there's often a question of across all these roles, there's a lot of different capabilities, a lot of different responsibilities. Do you see the same people that are kind of engineering data and preparing it, also the ones that are analyzing it? So when we think about data mesh, it can kind of be applied at different places. You have to think, do you still try to standardize data ingestion? When you're connecting to disparate sources and just in effect copying one for one, do you keep doing that at scale with the kind of centralized unit? I'll talk about some of the challenges later, but often there's kind of slowness to react and sometimes a lack of really data awareness and understanding of when might data need to be restated because they're an issue. So when you think about the clean data, generally you would think this fits pretty nicely into a single domain. You're not really integrating data, you're just taking raw data and kind of making it more presentable. But surely there might be some like intersections where base data is used across different domains. So are you giving access to this data? Whose responsibility is it to clean this raw data? Who manages it over time? What if kind of business rules or requirements deviate from one another? Do you duplicate effort? And I think that same idea comes across with data integration. So how practically do you provide access across these different domains, which are presumably different data stores? Like who decides on access, who sets it up, who approves it, all those different operational steps. Surely there's like slightly different use cases for like using similar data. So I might be bringing together sales information and supply chain information and might have different domains having different perspectives. The supply chain perspective is probably different than the sales perspective, but they want to share each other's data. So how do you operate that? Do you live with some level of duplication where rules are slightly different and the lens is slightly different? I tend to think you probably do, because that's what kind of the business teams are demanding. But that might get tricky with this data mesh approach of and it is now, whether you think about a data mesh or not. This is one of the trickiest things to really get right, is that integration kind of business layer of data. So again, data mesh is kind of some interesting principles and ones we see applying, and certainly from our perspective, not suggesting this is the best approach, it's the way to go, but just wanting to share information on it, see why it matters, where some of these principles can provide some value, and think about how you could apply them. So I'll talk a little bit about that here. Some of the places that I think immediately seeing the principles that data mesh talks about already kind of coming through, and not already, but over the past number of years, and really the history of data analytics, these sorts of principles have always existed and might just be kind of refined in a different way now. So it might be good to call out those things. I talked about we talked about data lakes a number of times here. Some of the challenges with the centralized data lake is speed and sometimes quality, the ability to evolve. Data schemas change over time, business rules change over time or need to be refined. How are you responding quickly enough to kind of meet the pace of business? Sometimes disagreements in priority. When you have priority coming from different business units that frankly don't really care about one another all that much, how do you decide like which data to ingest, which objects to create, and really ultimately evolving things in a true DevOps manner? So how are you introducing enhancements and features, maintaining high quality? A core aspect of what we do is the collaboration between IT and business, and it will continue to be at the forefront of kind of data analytics strategy and effectiveness. Some things with the data mesh that I might think about is within business domains and business teams, do you have the right amount of technical expertise to run initiatives, or are you able to bring in that expertise from an enablement team or a center of excellence team? So one of the questions is how do you embed that understanding of end-to-end data solutions, of data architecture, of deployments and DevOps into a kind of business-oriented group? And similarly, if you're bringing in those kind of technical roles, how do you make sure they do understand the business cases, understand why this data is valuable, how to work with it in the best way, and how to operate with efficiency? So again, the same sorts of things we've been talking about for years, and data mesh kind of presents it in a little bit of a different way. Obviously, all organizations have some sort of structure to them, how they organize, how they divide, and that's an aspect that is pretty core to data mesh, and that there's definition of these different domains, and it matters quite a bit because it's defining kind of how data will be situated within the organization, how it will be owned, how it will be stewarded through its maturity. Certainly, we've seen things split by technical functions. So you might have your ingestion team, your kind of data curation or transformation team, those building front-end screens and those doing data science. In some cases, and kind of our general thinking is you'd like to have that kind of done together, done in combination, kind of approached in this with the same group. Another kind of cut is by business function, so the same sort of idea of the data domains in a data mesh, but certainly that gets tricky just practically. How are you making these divisions? How are they evolving over time as new data comes in? And then I mentioned this a couple of times. It's often cited and just general thinking that sometimes the speed of business can run into IT bottlenecks because things are complicated to do. Things take quite a bit of time to understand, deliver, test, deploy, maintain, all those sorts of things. And on the other side, if kind of seen in situations where business analyst teams trying to deliver enterprise grade solutions might not have a complete understanding of technology, how to apply it to best effects, things like deployment. So how do you mesh all these different large vast of knowledge and understanding of situations and systems and bring it all together to really tackle data analytics with some efficiency and intention? So Harpreet talked about this a little bit, but how might we see a data mesh approach kind of materializing? And this is kind of generalized and builds off some of the topics we've talked about. You'll likely still have those IT controls, so defining infrastructure, setting up infrastructure, understanding the needs for compliance and security. I still think there's a role for kind of standardized systematic ingestion. Maybe it's not everything, but things like core SAP data, core systems, which you should be able to be done at scale, with kind of fairly similar patterns. You think you should still be able to kind of present that into a domain pretty seamlessly. The data products, which again are kind of business led, but I think it has to be maybe stop calling it business and IT, but kind of the data products or the product team, where you have understanding of business, understanding of technology, and the application of technology all into one. So it's kind of getting rid of some of those titles and thinking about what skills do we really need. And you would think these data products own ingestion, data visualization. You can see some of the other things here, the integration of data and the subject matter expertise, both of their domain and an extent across other domains. A couple different terms here: product governance, center of excellence, enablement team that Harpreet used. But here, having some sort of centralized definition of what is the data architecture, potentially data cataloging, security and access pattern, and potentially some suggestions. And this is a hard one: is to what extent do you enforce best practices? You don't want these disparate data stores, data products to be wholly different. They'll be on the same technology stack, presumably, but what if naming conventions are totally different? What if the structures are totally different? If the approaches are totally different, does that become hard to integrate then across domains? And then something else, not exactly sure physically what this is, but some sort of interface that enables really the self-service empowerment to work in one's domain and across different domains. So how do I know what's available out there in domain X, and how do I let people know in my domain how to get access to it? Who decides who has access? How do we differentiate what they have access to? They might need access to 10%, but not the other 90%. How do I get technical support? So what does that physical interface looks like? Is that just documentation? Is that a team? It's hard to really say. Just a few challenges, and I think I've listed a few here already. Identifying the skills and talents. So we're kind of looking for broad range of skills: technical, business, communication, lots of other things. Getting those, and that's maybe the challenge across everything, is getting those right skills in place is imperative. Definition of data ownership. So over time, data evolves, business units evolve, demands evolve, organizations reorganize. So who manages disagreements? Who's making the ultimate call? Cross-domain, true cross-domain data sets or applications, how does that get managed? I talked about this just briefly before, but the practicalities of data sharing, we have to be granting access. Who's deciding that? Who's functionally deciding it? Who's deciding if it's appropriate or not? And who's going in and assigning access for physical users or identities or service accounts or whatever it is? I think of these if we're giving teams like puzzle pieces to put something together, if those puzzle pieces might fit in isolation, but if the whole puzzle doesn't fit, you've kind of lost it. Can that enablement team really have enough influence? Can they understand the nuance that's happening across domains? Can they play an active enough role? Do they have enough capacity? All those sorts of things that come up, and deciding how strictly are standards enforced, and at what cost is that overbearing versus losing control. And then even within a domain, there's still lots to worry about. You've got the ingested data. We're thinking about that. That's a kind of continuum of data maturity. How do you decide on that? Do you operate like we traditionally have, where we might split these things up technically? I think we tend to think you want to approach it more holistically, where you're not thinking about an ingestion team, a transformation team, a reporting team, but thinking about our data team, our product team, and tackling these things in unison. So quick close out here, and I'll build these pretty quickly because we're about at time here. Just a few kind of things to think about with data mesh, some reasons to read up a bit more on it, to ask about it, to inquire about it. I think the velocity and rapid iteration that empowers teams to work with. So working with speed and agility and kind of keeping the business objectives at the forefront, and really putting the teams that understand the data, understand what the business is trying to achieve, like in control, makes a lot of sense. Obviously, we know data is exploding, more and more data sets becoming available. The volume and the breadth of data is insane. How do you get that right, both internally and externally, to share data? So that's kind of a key unlock of data mesh, is data sharing effectively and maybe being intentional about it. Of course, the complexity is doing it, and a few more here around the kind of alignment of or kind of rethinking organizational theory, which comes with data mesh. Are there things about data mesh principles that you might want to adopt to your organizational theory? And the last point to make is the technology is really there with the scalability of cloud, and Harpreet mentioned this, the ability to automate setup, self-scaling services, the reusability of DevOps, CI/CD, and those sorts of things. It's there to accomplish some of these things in data mesh, which gives us a footing to maybe try. I'll quickly wrap up now. Just a few things across what kind of Thorogood operates. You'll see them listed here. We work across data engineering, data science, data visualization, and kind of are helping with our customers across different things, whether it's actual implementation, so building systems, defining architectures and strategies, empowerment and enablement, and kind of everything in between. So a topic with data mesh that we're interested in. If you'd like to talk about it here a bit more, do feel free to reach out. So with that, thank you very much for coming along today and listening in. And here are contact details if you are interested to get in touch, share some of your learnings, ask some questions. Always happy to chat. But with that, thank you and have a good rest of your day.